This is the last section of our linear equations and linear relationships topic, and we're looking at graphical solutions to linear simultaneous equations. So graphical meaning we're going to draw graphs in order to solve simultaneous equations. Now, earlier in the year, when we were doing chapter 2, we looked at solving simultaneous equations by using substitution and elimination. So those are the two algebraic methods we used. We did briefly talk a bit about what it means to find the equation of simultaneous equations, the solution, but we didn't really do a lot of work with it. This third method that we can use is if we draw the two lines onto a number plane, we can find the solution to simultaneous equations by finding where they intersect. So this is another method. This is a less accurate method, like we could see when we were looking at using graphs to interpret data. Sometimes you may not get a perfect answer. You can get much more accurate results by solving the algebra. But this is another method that we can use. So we're looking at, first we need to graph two lines in order to find where they cross over. So in these examples, solve the following sets of simultaneous equations by graphing them on the number plane. So the first thing we're going to do is graph these. Now remember, we've got a couple of methods that we can use. One is you can use the gradient intercept form, and then you've also got the method where you find the x and the y intercepts. So those are the ones that you should be using more of. Generally, you shouldn't be drawing up a full table of values anymore. Okay, so we want to find the shortest possible ways in order to draw these lines. When we're looking at these equations, with this first equation, I would actually use the gradient intercept form in order to sketch that. So y equals 2x minus 2, we need to first work out what the gradient is and what the y-intercept is. So when we're looking at that equation, we know the gradient is 2, or we can write that as 2 over 1. Remember, that's rise over run. Okay, that's going to be important when we go to draw this line on the number plane. The y-intercept, the c value, is negative 2. So using those two values, we can actually go and draw this line. So I'm just going to draw this one in red. So we're going to start at the y-intercept at negative 2. And then we're going to work out a second point using the gradient. So we've got a rise of 2 and a run of 1. So we're going to go 2 units up and 1 unit across. So then that's going to be another point on the line. So then what we're going to do is draw a line straight through the middle of those, and that's going to be the line y equals to 2x minus 2. The second line that we had was x plus y equals to 4. Now with this equation, I would actually prefer to use the intercept method because I've got x and y on the same side. So when I make x equal to 0, then I can see clearly y is equal to 4. Okay, so think about if I make x equals 0, 0 plus y is 4, so then y must be equal to 4. Okay, so that's why I know that that works. What I can also do is when I put y equal to 0 in, then what I've got is x plus 0 equals to 4, so that means x is equal to 4 as well. So that gives us the 2 points that we're going to use. I'm going to draw this one in green. So we know that 0, 4 is a point on the line. So 0 units across, 4 units up. And then the second point was 4, 0. Okay, so remember, x comes first always. So 4 zeros down here. So we're going to draw a line straight through the middle of those. And that's going to be the line x plus y equals to 4. To find the simultaneous solution, that's the value. What color should I use? I'll use purple. That's the value right there. Okay, so where the two lines cross over, and that point there is 2, 2. So what we know is if I put in x equals to 2 and y equals 2 into either of those equations, both of those equations are going to work. So if we want, we can check them. So if I check that one, 2 equals to 2 times 2 minus 2, we can see that's true because we've got 2 times 2, which is 4, minus 2 is 2. So we know that's going to work. The second equation is 2 plus 2 equals 4, and that's very clearly true as well. So then we can say the simultaneous solution is, we can write it as a coordinate, okay? Or you could write it as x equals 2 to y equals to 2. Let's have a look at the next one. So we've got y equals to 4x minus 6, and our second equation is y equals to 2x minus 4. So they're both in gradient intercept form, so I might go with that. So y equals to 4x minus 6, gradient is 4, or 4 over 1, and the y-intercept is negative 6. So when I go to draw it, I'm going to be at negative 6 on the y-axis. I'm going 4 units up, 1, 2, 3, 4, and then 1 unit across. So that's where I'm going to be passing through. So my line is going to look a little bit like that. So I really should be drawing it going through the point 6. Just haven't quite gone there yet. There we go. Alright, so this is the line y equals to 4x minus 6. What we're also going to do is work out the other one, 2x minus 4. So the gradient is 2, or 2 over 1, and the y-intercept is negative 4. So it's passing through negative 4, and we're going 2 units up, 1 unit. Oh, there we go. I think we've already got our simultaneous solution. So 2 units up, 1 unit across. We're going to end up there. That's y equals to 2x minus 4, and clearly that's exactly where the two graphs intersect. And that value there is 1, negative 2. So we can see that that's going to be the point where they're both equal at the same time. So then the simultaneous solution is 1, negative 2. If you want, you can go and use the algebra to double check these. Okay, so remember we did elimination and substitution. You could use either of those, and what you'll find is you should get the same result. Now, when you're drawing these graphs, so when you do the questions, you will need to draw these to scale. So you might want to get some grid paper, maybe print a bit of grid paper off. You should be able to find some online if you need to. But they do need to be to scale, or you need to measure it when you're drawing it in your exercise book. And that's it for this topic.